question 6, I'm going to get out my page with the summary of all the rate laws that was in the lecture outline. And there are really 3 rate laws that we're looking at here: 0th order rate law, 1st order, and 2nd order. And the thing about what we're about to do is that when we look at determining the rate law graphically, and we have some pictures of graphs here. So one thing that's different is that there will only be one reactant. So if we were to draw this reaction, we might say A goes to products. And it's not A plus B, because then we'd have to determine B as well and the rate law for B. And so if you have more than one reactant, that's when the method of initial rates, you need to do it. So more than one reactant. So this method doesn't work. Use method of initial rates. But if you've got one reactant, then determining it graphically is actually turns out to be a simpler way to do it than doing all those experiments that you need for the method of initial rates. And so for the 0th, 1st, and 2nd order, we have the rate laws right here. We have the integrated rate law that we went over how to derive these results. Specifically, I know for the 1st order in the lecture outline, but we've also can integrate to do the 0th and 2nd order as well. We have units, and we have the linear plot. And again, these are things that we talked about in the lecture outline. For the lecture outline, if you plot natural logarithm of the concentration, just like you see in the integrated rate law, versus time, you will get a linear plot if it's 1st order. And whichever plot is correct, the slope is related to the rate constant. And we didn't talk too much about this, but we'll turn out the half-life formula for 1st order is the most important of these. And the half-life for 1st order has direct applications to nuclear decays or radioactive decays in nuclear chemistry. So I keep this with me while I do these problems. I see that I've got 3 plots here, and that one of them is linear. And since it's 1 over concentration versus time, and since the plot says, or it's my summary of all rate laws, says 1 over concentration versus time is the linear plot if it's 2nd order, that means that my answer is 2nd order for this question. And you'll also see that the other ones are not linear, so natural logarithm of concentration versus time. If this one was linear, that would mean it's 1st order. If concentration of A, just concentration versus time, was linear, that would mean it's 0th order. And that's what it means on this page when it talks about the linear plot. Any questions about that?